Math is starting to get very interesting. Today we're going to take what we learned about functions and we're going to apply them into something called linear equations. Now, by definition, the word linear means line. So that means we're going to have equations that simply create a line. Now, there's always a relationship between my x value and my y value on that coordinate plane for that equation. Therefore, every linear equation is a function. So we have what's called function form for linear equations. It's the way we always want to write linear equations. And that form is simply y equals mx plus b. Now you don't need to know all of those letters yet, but what you do recognize is x and y. And you know that x and y are a part of our coordinate plane. So that x value always talks about that horizontal line on the coordinate plane. The y value always talks about the vertical line. So when we see that x here and y here, they are talking about locations on that coordinate plane based off of the x-axis and the y-axis. Now, every linear equation can be graphed on the coordinate plane. So if I have this linear equation here, y equals x minus 4, I know it forms a line. And a line can go on infinitely long in both directions. So what I'm doing when I graph a linear equation is I'm finding every solution to that equation, which means every xy value that will be on that line. Now, I don't have to show every xy value because if I put the line and I put my arrows on the end, it just means that it goes on forever and ever. We just need to capture a portion of the line when we go to graph linear equations. Now, sometimes our equations are not in function form. And if they are not, we cannot begin working with them. We have to make them in function form. So it has to be in this y equals mx plus b format. So if I get this equation here, notice my x and my y are both on the same side of the equal sign. That tells me to stop right there. I need to change that equation around and I'm going to use inverse operations to balance it out. But really what I need to do is I need to move this x value to the other side of the equal sign because the y and the x are always on opposite sides of the equal sign. So I simply take my 3x and I subtract it from this side, which means I have to subtract it from this side because I have to keep that equation balanced. When I do that, I'm still left with my 2y on this side because I didn't do anything with that. But on this side, I now have my -2 and I have my -3x. Now notice, I didn't line those two numbers up because they're not the same thing. This has my variable. This is just a number. You cannot put those two things together. And I also know that I always put that x value first. And so what I did is I reversed the order and I put -3x first. And I put this -2 second. Now I'm getting closer to my value, but notice it's a single y. I can't leave it at 2y. I need to get rid of that 2. So I'm going to use inverse operations to get rid of the 2 as well. So I'm going to divide by 2, but remember to keep it balanced, everything has to be divided by 2. So I divide by 2 there, I divide my -3x by 2, and I divide my 2 by 2. When I do that, I'm left with my y. I'm -3/2 x, and lots of kids look at that and they think, oh, I don't want to work with fractions. You're going to see in later lessons that these are actually really easy to work with. So don't think of them as fractions, just think of them as a ratio. And then I have -1. Now notice, now I'm in my linear equation format. It's called correcting the format. Once I've corrected that format, then I'm ready to start working with my linear equation. So we're going to get different types of lines that are on those coordinate planes. Now we always read our coordinate plane from left to right. And so if I'm going from left to right going up, that's called a positive slope. And we understand the concept of slope because it's like going up a hill. So I'm going up the hill, that's a positive slope. Or I could have a line that goes down from left to right. That's like going down a hill, so that's a negative slope. I can fall off a cliff. That's called undefined. It's not a slope at all. We don't want to usually fall off of cliffs, but we can also have a zero slope. That means we're just walking and it's just flat ground as we go. So those are the types of linear equations that you could find. Now notice not all of them are functions. If we do our vertical line test, which tells us if it's a function, we can see that a positive slope is a function, a negative slope is a function, but we have a problem there. Undefined means that it is not a function. That means there's no relationship between that x and that y value. But a horizontal or a zero slope is a function. So this type of equation has a relationship, this has a relationship, and this has a relationship. Therefore, they're all functions. This undefined is the only one that does not have the relationship. Now, you're going to be asked to do several things when you're dealing with linear equations. And one of the things they're going to ask you is, well, is the ordered pair given a solution to that linear equation? Well, these are the easiest ones to solve. So remember that first value of the ordered pair always is our domain or our x value. You can think of it as that input-output machine. It's the number that goes in the machine. Our y is always our output number. Once the number has gone through the machine, that's called our range. So if we want to check to just see if that ordered pair is a solution, which means it has a relationship, we just plug it in. So notice my -4 is my y, so I have to substitute it in for y. And my 1 is my x, so I substitute it in for x. Then I just solve it. And remember, by definition, equations have to remain equal. This side has to stay equal to this side. If both sides are equal, I know I have an equation. If one side is different than the other, then no, I don't have an equation. It is not a solution. So when I plug it in, I get -4 equals -2. Well, notice I'm out of balance. And if I'm out of balance, then no, that is not a solution. If it was -4 equals -4, then I'd be in balance, and yes, that ordered pair would be a solution. So those are the easiest ones to do. Now, sometimes they're just going to say graph the linear equation. It means you got to go find the line. Well, there are several different methods to doing this. I'm just going to introduce the first method, and that is called making a t-table. Now, remember, that line that forms that linear equation goes on forever and ever and ever on that coordinate plane. Well, I just need to find the portion of it. So I have a strategy that I always use, and that strategy is I want to get as close to that origin or where that x and y axes cross in order to just find my line. So I don't have to have a huge coordinate plane. So no matter what, I always choose for my values for x, -1, 0, and 1. What I did is I want to find the line that goes through -1, 0, and 1 when I find my ordered pair. Now, every line has to, because by definition, that line will go on in an infinite length. So when I do that, then all I have to do is come back to this concept of substituting. If I've chosen -1, I take this equation and I literally substitute -1 in for x, and I solve it. So I do 2 times -1 minus 3, that becomes -2 minus 3, which is -5. That means where it goes through the -1 value for x, it pops out at the -5. Think of the machine. -1 goes in the machine, -5 pops out of the machine. Then I substitute 0 in. So 2 times 0 minus 3 is 0 minus 3, which is -3. That means 0 went into the machine, -3 popped out of the machine. And then I substitute 1 in for x. 2 times 1 minus 3 equals 2 minus 3, which is -1. Now, when you go to find a line, you need 3 points just to make sure that you get that line exactly correct. You could have chosen any 3 points. I could have chosen negative a million, 0 and a million. But the problem with that is I would have had to have a coordinate plane that goes up to a million and down to a negative a million. That's way too big. So by keeping these numbers -1, 0, and 1, it keeps us very close to the center of this coordinate plane, and I only need a small coordinate plane. Now we know this is a linear equation, so I'm expecting a line. So when I go to graph and I do -1, -5, I put a point. I put 0, -3, I put a point. And I put 1, -1, I put a point. Once I have my 3 points, all I have to do is connect them with the line. So the drawing or the picture that goes with this equation looks like this. And that's the beauty of linear equations. We are now entering the world of math that becomes a little bit more artistic, and there's a drawing that matches the equation. Most kids didn't realize that math actually can be two-dimensional with drawings. So it's up to you now. This is a fun new thing that we are starting to do. I hope you enjoy it. Good luck.